Hello and welcome to this video where I do an introduction to Retrieval Augmented Generation, or RAG. So, first up, what is RAG? RAG is just feeding the model with relevant information at runtime. Retrieval Augmented Generation. You feed it with information that you've retrieved at runtime so the model can be better, right? And so, for example, if the user asks about the most recent sales forecast, right? Like if somebody asks, hey, was this week's sales higher than last week's sales or whatever? You can then feed in all of the necessary sales forecasts into the context window of the model, and so the model just doesn't hallucinate. And so this is obviously the difficulty of it is changed based on how much data you're trying to feed in and whatnot. And this is because models have finite context windows. You can't just throw everything in there. And so now, first, let's look at some of the ways we can actually do RAG, right? Like how can we actually take this idea of RAG and actually execute on it in the real world? First, obviously, simple prompting, right? So this is like, hey, today is Sunday, September 22nd, and the user's name is Sanjay Jairam. Like, this is just a really simple way of just like saying, hey, here's the necessary information. We, the application developer, have retrieved it for you. This is all the information you will need. Now, obviously, this isn't the fanciest way of doing RAG, but like in some instances, it can be like helpful, right? Like if you're trying to do like a very specific RAG system, like, hey, this is a chatbot, and all it knows is our like last two sales forecasts. You can ask it about how this week is different from last week or whatnot. This makes more sense of just like just putting it in the prompt, right? Maybe you change your runtime, but all you're doing is just putting it in the prompt. You just like swap out the text, and this makes sense in a few cases. But I think the method that works in a lot more cases is vector DBs and cosine similarity. So what it is you take all the necessary documents, right? So for example, in the sales forecast example, you take all of your sales forecasts from like the past however many years, and you put it into a vector DB, right? And so then when the user asks like, hey, how do our sales this week compare to the sales at the same time last year, right? Because maybe your sales are impacted by like holiday spending and whatnot. The closest documents are fed into the context of the model. So the actual, like you say, this time last year, you put that into the the vector DB, and the vector DB will be like, because it's like talking about right now as well as 1 year in the past. So you say, let's assume it's like December 15th, right? So you automatically put like December 15th in there. Then you automatically get the December 15th forecast here and then 1 year ago, right? So you just get the most relevant pieces of information, and then you feed that into the context of the model. And so then the model can go do what the model does, right? And so what you're able to do here is you're able to have a more like runtime dependent like querying, right? So if the user asks, hey, why exactly did the Romans invade England whenever they invaded England or whatever, right? Then if you say, for example, all of Wikipedia in a RAG system, you could then feed the correct Wikipedia article about like the Roman invasion of England and then bring that into the context window of the model, right? And so you can now effectively have a model that understands everything and you can ground it properly. But this is a little bit of work to get going. Now, of course, there's another level above this, which is specialized AI agents, right? So you have different AI agents that are specialized in different topics. And the AI agent, talking to the user, intelligently picks which specialized agent to ask for more information. So let's say you run like a car dealership, right? And so you have a bunch of AI agents. And so in essence, the user, like the actual end user, like sends a message saying, hey, are you guys free at like 2 p.m. at your northeastern location for an oil change or whatever, right? And so then this model will then go out to the AI agent, right, the LLM, that has all of the northeast location data, right? It has access to all the tools and whatnot, right? So you effectively have like a vector DB cosine similarity occurring there, but this is based on what the model is asking for. And so effectively you can have like a network of these agents kind of doing all of your business and whatnot. And so you're effectively, what you're able to do is you're able to just have like a much more specialized system, right? Because maybe the user asks about the northeastern location, and so you don't actually have to have a system that deals with any of the information from the southeastern location or whatnot. And so you're now able to just have a system that's way more specialized and focused. And maybe you can have different models for different types of queries, right? So you can say, for example, put like a really cheap model for the main user query that has a lot of tokens going in and out, but then have a more expensive model in the back doing stuff. And you can't really do that with just vector DBs and cosine singularity. With vector DBs and cosine singularity, you just have a few knobs to turn it, and there's like not a crazy amount you can do. Whereas here you have a lot more flexibility. Now, of course, the highest level and the most difficult thing is what Google's doing, where you just throw everything in the context window. You just build a model with a multi-billion token context window that can handle literally all of your documents. Now, for most of us, we don't have the resources to do this, right? The only people who have the resources to do this is like Google, Meta, and whatnot. And the only company that actually has any model capable of potentially just replacing a RAG system with just context window is Google, right? Like Gemini is the only model, as far as I know, with an effective context window that's more than like 500,000 tokens, right? Like Gemini has the 1 million context window and then the 2 million in experimental mode. And so, for example, if your entire data set is like effectively one textbook, which is like probably like 1.5 million tokens or something, you can just feed that into the context window, no RAG system necessary, right? And so, depending on what you're doing, maybe this is an option you should look for, not in the build your own model kind of way, but see if Gemini is able to just solve the problem. Though, of course, if you're trying to optimize price, maybe you're looking for Ollama 3.1 AP and then you have to do more complex RAG. And at larger scales, RAG does become better because the longer your context window, obviously the more compute you use, and so probably the higher price. Cool. Now, what are we building? We're building just a vector DB and cosine similarity system, right? Maybe in the future we'll do specialized AI agents, maybe some tool use in there. But right now we're just doing a simple vector DB plus cosine similarity example. Cool. Now, let's get building. Okay, so now we actually get started on writing the code. And so the document I'm going to be using for this example it's just going to be the Meta Chameleon technical paper and the Gemma 2 technical paper from Meta and Google. And so I'm going to be using those as my documents. So obviously first to show off that the model doesn't actually know what they're talking about, we're going to run Ollama 3.1, which is the model we're going to be using, right? And then it's going to load into the GPU and all of that type of stuff. And then we're just going to ask it, like, what is Chameleon, right? And then it's going to tell us something about the animal. Like, what is Chameleon? It's a type of lizard, and it's like, okay, that's not what we want. We want to know about the Chameleon model. And so for that, we actually have to feed it the technical document. So what we're going to do now is we're going to initialize a Python environment here, right? As usual. We're going to make a new virtual environment. I'm going to call this the RAG tutorial environment. Name it whatever you want. This is just a virtual environment, right? So, right now I'm just going to call it. Well, first we have to import our libraries, right? So we're going to install. What we're going to install here is we're going to install Ollama, right, to access the LLM. We're going to install ChromaDB because that's a vector database of choice, and we're also going to install PyPDF because that's how we're going to access the PDF files. And so obviously, I've installed all this stuff before. It's pulling from the caches, but yeah. And it's just like putting it in folders, setting it all up. And then from there, what we're going to do is we're just going to create the file, right? Env main.py, right? And so here we are in main.py, and so first, obviously, we'll import our libraries, right? Right, cool. Now what we're going to do is we're going to set up the ChromaDB client, right? So, from our client equals ChromaDB dot client. Right, we're just going to set up the ChromaDB client. And because we're running this locally, we don't actually need an API key. We'll just connect to the local ChromaDB. If you were saying this on a server somewhere, then you might need to set up an API key and all of that. But for now, we don't have to. Right, and so we're going to get the new collection. So, Chroma client dot get or create collection, right? So either this is going to get the collection, or if it doesn't exist, we're going to create the collection. And I'm going to call this RAG tutorial, right? The RAG tutorial collection. This is just a name of effectively the database table. If you want to consider this similar to like a regular database, right? This is similar to just like the database table, And so you have the collection. Now I'm going to make an upload PDF function, right? So we can just feed it a PDF file and it'll upload it. File path, right? And so now, first we're going to set up the PDF reader, and it's going to be PyPDF dot PDF reader, and obviously this has to take in the stream, and so this is going to be taking in a file. I forgot to actually like open the file, right? So with open file path, comma, read bytes as f, right? We're gonna read as file. We're going to read the file. Then what we're going to do is we're just going to set up the thing, right? So we're going to set up so first, obviously, we need to set up the ID, right? Because every time you upload to ChromaDB, you need an actual unique ID for each different document. So this way, ChromaDB can vectorize the document, like embed a document, and then compare it with your ID, and from the ID, you'll get the base text, right? So first, you compare closest vectors, and then you find the ID of the closest one, and then you get your base text. So, cool. Now, for page in PDF reader dot pages, right? We're just going iterating to every page. And what we're going to do is we're going to have every document be one page in the like base text, right? So we're not going to do anything like any fancy chunking or any of that. We're just going to have it be like every page of the document is its own bit of text that we can like retrieve individually or whatnot. And so then what we're going to do collection.add, right? We're taking collection as a global variable and we're running add on it. And then in it, we're going to have the documents. We're just going to include the page, and then we're going to extract the text from it. And then for the ID of the page, what we're going to have is we're just going to have a string that's going to be, it's just going to be the file path plus the ID, and obviously ID plus equals 1. And that's it for our upload PDF function. We're just going to be going through every single page, and we're just going to be uploading it to our ChromaDB. Now from here, we handle the actual upload of PDF. So I'm going to upload PDF, and here I'm going to upload the Chameleon tech paper, and here I'm going to upload the Gemma 2 text paper. And then now we can handle our LLM stuff, right? Because now our documents are in a ChromaDB, we can handle any of that. So now what we're going to do is we're going to get the query from the user. It's just going to be a simple input. I'm not going to do like a multi-turn conversation type stuff. I'm just going to have it be one shot. A good thing to do after this point is take this code and make it multi-turn, right? Like have it get the relevant documents every time, make it multi-turn. And also put some of your own documents in this. Don't just put like LLM tech reports. Maybe put in like maybe Wikipedia pages, right? Like take the HTML of a Wikipedia page and put that in as into the ChromaDB. Like just try a bunch of stuff, you know? That's how you'll learn more. Now what we're gonna do is we're gonna get the closest pages right from the ChromaDB. And so the closest pages, that's going to be collection.query. So we're making a query to the collection. And so our query text, because it takes a list, is going to be a list that has query. All right, and so the reason it takes a list is if you want to do multiple queries at once, you can do this and it's going to be faster, but we only want to do one at once. And let's just feed the LLM the 3 closest pages, right? Like this is so that maybe the most similar one doesn't have the stuff, but maybe some of the lower ones have the information we want, right? Then we're just going to get the response from Ollama. And then the model, we're going to use Llama 3.1. Now, of course, you could probably get away with using a smaller model. Like maybe you could get away with using like a 0.5B model here, right? Because you're feeding it very relevant information. And so like the better your rank is, you can probably get away with using a smaller and smaller model. It's just Llama 3.1 is a nice size and it's a really good standard for everything. So that's why I'm using it here. So the message is, we're going to be a little cheeky here. Like this is not going to be good code. This is just purely an explanation. We're just going to, so obviously roll system, right? Because every thing has to be a system prompt. And then for content, in each message, it's going to be closest pages of, we're gonna get documents from it, because it also gives us the IDs of 0, right? Now we're gonna be very cheeky. We're just going to copy this code and we're just gonna paste it twice more, and instead of the 0 document, 1, 2. Like, this is not good code. Don't get me wrong. This is not good code. However, it doesn't particularly matter for this because this is purely illustrative, right? Like, this code is not going to production. It exists purely to illustrate how this works, right? So, and then obviously we have to get the user query in here. And then the content of it, that's just going to be the user's query, right? So effectively, what we're saying is we're giving it these three different like pages in a document, and so the document's a little bit long. Like, there's more than 3 pages, so we're just getting the 3 most relevant pages, and we're just giving it to it, and then we're just letting the LM handle it, right? And there's system prompts, and like in a real use case, what you probably do is you probably do like chunking, where like every few, it's only a few hundred characters, and you get a lot more of them, so you can get a lot more of the relevant samples and whatnot. But here we're just doing like the quick and dirty, different system messages and different pages, go deal with it, right? Like, this is not the best way to do things by any stretch of the imagination. And then from here, what we can do is we can just print, right? We can print response of message of content, right? And so from here, that's our code, right? Python 3 main.py, right? And so we run from the code, we have a prompt. I will ask, what is chameleon, right? And it's gonna like effectively run it'll run through the code. It'll get the closest one. Chameleon appears to be an AI model that can process text as well as images, right? It's exactly what Chameleon is. Its name is Chameleon because it can adapt and change based on the input prompt, much like how a chameleon changes. This is exactly what we want, right? Because if we run, again, Llama 3. Right? We just run it on Llama 3.1. We ask what is chameleon. It's not related to what we are asking about, right? This is about chameleon the animal. This is not about chameleon the AI model. And so, in essence, what we've done here is we've actually taken the data for what we want, and we've grounded the model in the type of stuff we want it to be. So if you feed it like a ton of AI information, and then like put it all in like a vector DB and do that type of stuff, you can have a model that's very similar to like vector DBs, right? Because like obviously Llama, like we can ask what is Llama. Oh, it's even going for the Llama the animal here, not Llama the AI model, right? Like we want to talk about Llama the AI model, but like it's not here, right? And because at least in the AI sphere, you have a ton of like overlap in names because Llama is an animal and chameleon is also an animal, and it's like a bunch of animal names are here as well. Like if you want to talk about AI models, you kind of have to do something like grounding and drag and whatnot, and like here's a method to do that. This is a very simple, very rudimentary method, right? But going from this, you can take it and you can extend it into the future to do kind of whatever you want it to do. And yeah, I'm going to leave it at that. Thank you for watching. Please like and subscribe under the video. Thank you. I will see you all in the next video.